Fascinating discussion tonight with Andy Lloyd, the Dark Star, back with more of his theories on Coast to Coast AM. And welcome back to Coast. Andy Lloyd with us. Andy, back to your thoughts and series. Have you had a chance to talk with Zecharia Sitchin about your proposals?
I've written to him, and we've had some correspondence down the years. He's not an email fan. I don't know if you've ever picked that up.
Yeah, no, I have. He's and he's getting up there in age.
Yeah. And I tend to do everything by email, and because I live in Britain and he lives in New York, it's not easy to go and exactly jet over and see him. In fact, my editor lives in New York. Hi, Lee. I'm sure you're listening right now, chap. And ideally, let's go over there, but I'm not a big fan of flying, I'm afraid. So the opportunity to be in contact with Zecharia has not been great, but we've exchanged letters, and he's always interested to hear what I have to say about various things. And if I come across something that I know will interest him, I send it along. And when I have put the brown dwarf idea to him, he says, well, he's paraphrasing him, I suppose. He says, well, maybe it is. He says, but it doesn't make a huge amount of difference because it's a planet, From his point of view, he's really just trying to establish the fact that there is this Planet X type of object, this 12th planet, that is moving through the solar system periodically and bringing to us the gods. And he's concentrating very much on what's going on when they arrive and when they're here. So yes, I think he's open-minded about it, and
it really doesn't slap his theories down.
Not particularly, no. I mean, it's like it's adding something onto it that creates a bit of more scientific context. And I'm still a fan of his, and I still enjoy his books, and
it might make it more possible.
Yeah, absolutely. This is what I've been trying to argue, but. As the years have gone on, when I first put this forward in 1999, it sort of, people listened to it and they thought about it. And as I noticed, as the years went on, Planet X and a brown dwarf on the Internet just became interchangeable phrases.
Yes.
And so you could sense that, and I don't think anyone realized where it come from. It just kind of happened. So Sitchinites would say, well, this isn't what Mr. Sitchin's saying. And it all kind of just got into the soup. And the Planet X soup is a soup. I mean, I'm sure you're aware of that as well. There's all kinds of stuff gets chucked into
Andy, you know how people would love for the Loch Ness Monster to be a plesiosaur, a dinosaur, as opposed to an eel or a huge seal or something like that. People want it to be romantic. They want it to be something, mystical. A dinosaur is that. I think in your case, too, it's the same. What you're battling, and you can very well be right, is with Sitchin's theory, which is very similar to yours in terms of being close. He's talking about a planet by itself. You are too, but it sounds like it's a planet. I think people want it to think of it as another planet out there in the solar system that we can't find, as opposed to a brown dwarf that has a moon which acts as a planet. I think people just have their own different kinds of perceptions of stuff.
Absolutely. And I'm adding a degree of complexity onto an already complex theory.
Yes.
Which, this is the whole thing. People like stuff simple. And when science isn't like that, science is incredibly complicated and gives you a headache. And you have to work with degrees of probability rather than definite answers. And it does make the whole thing more complicated. But, when you're working with this, you're dealing with a lot of factors. You're dealing with a lot of the text that he works with and the ideas that come out of that, and then trying to amalgamate that with the scientific understanding of what's really going on. Because for Sitchin to be right, it's got to work. It's got to make sense so that, when this, and I say when because I'm absolutely convinced it's out there, when the Planet X object is discovered, it's a plausible scenario with some sort of concrete physical underpinnings. You see it, it's a planet, there's life around there, and we have to all adjust to the new reality, which is that we are not alone.
How big do you think this NIBIRU, which you believe is a moon of this a brown dwarf, how big do you think it is as a moon? Well,
let's take that back just one step. The Anunnaki themselves appear to be very similar to us. They're sort of bigger versions of us. But they
or the other way around.
Well, yeah.
We are they, I guess.
We are they. We are the little guys, and they are slightly bigger than us, but they're more godlike, aspects of ourselves. So if they're capable of living on Earth reasonably comfortably, and
atmospherically and things like that.
Yep.
Okay.
Then their conditions here have to be approximately the same as the conditions on their homeworld.
I would agree with that. That's right.
So my understanding of this would be really, you don't have to make a great leap here. Their world has to be similar to Earth. It might be a bit bigger, it might be a bit smaller, it might be a bit denser, it might have more water or less water. The atmosphere and everything, the atmosphere is crucial. It's got to be very similar to ours. So really speaking, again, when we were talking about panspermia, I'm a great advocate of believing that life is everywhere.
Me
and
too.
It's just waiting to be found.
Yes.
And the Earth...
And it's very similar, by the way, I think.
Yeah. And the DNA, the backbone of life here, is the same backbone that you're going to get throughout the galaxy. So once life's seeded, it's a natural development for it to go through a number of strategic advancements towards life that's very similar to here. And, the human form, it's sort of handmade, really, by God, if you like, but it's the perfect pinnacle of the evolutionary process. And that process, I believe, could happen elsewhere. So humans I consider to be a model for evolutionary development throughout. So the Anunnaki would have evolved there, and they would evolve under similar conditions to here because that's how life works. It sort of opens up like a Pandora's box and everything just kind of clicks into place and, it's like a flower blooming. The flowers are all the same. And once they figured out how to technologically get over here to start using our resources, because perhaps, they started to do on their planet what we're doing to ours at the moment, which is use it all up, they decided, well, let's go and visit Earth. It looks a bit of a dangerous place, but we'll give it a whirl.
Mm-hmm.
And this is how I'm sort of seeing how things are moving. Because
and let's talk about how you thought they got here, based on some of the things Stanton was writing about.
Well, Stanton's really absolutely spot on when he writes about nuclear engines on spacecraft. People forget. They tend to think of rockets as being chemically powered rockets, and that's it. You stick a great big couple of stages on the bottom of a rocket, blast it off, and then you get going.
Mm-hmm, mm-hmm.
And he argues that, for years and years and years, the scientific establishment have sort of created this myth that you can't travel any great distance using conventional means. And they say, they send a Voyager spacecraft and it's getting out to the outskirts of the solar system now, and it's taken 30-odd years to get there. And so how long do you think it's going to take to get to a star? It's ridiculous. And he argues against this by saying, look, the reason why it's taken 30-odd years to get out there is it's not powered. It's like a slingshot. It's been flung out of the Earth on a rocket, and then it's done a couple of moves around past planets to speed up, but there's no drive that's accelerating this thing on. And in space, there's nothing stopping you. There's no reactive force that's preventing you from accelerating. So if you can get some kind of power behind a spacecraft, you can continue to accelerate continuously. And before you know it, you're achieving extremely fast speeds, and you can travel great distances. So if you're talking about a brown dwarf in the solar system that's, let's say, as a number picked out of thin air, 1,000 times further away from the sun than we are,
mm-hmm.
so that's 1,000 astronomical units away. If you stuck yourself on a rocket and powered it with a nuclear engine, then, you're going to get there. It might take a couple of decades, but you can do it. You can get there and you can get back. And if this thing does sort of move closer to the sun periodically, then the journey between there and here is going to be that bit shorter. Because at the moment, I think it's at its furthest point away. It's going to be a very difficult object to get to for us right now with our current technology.
And they still probably had a much more sophisticated propulsion system, I think, than we can even imagine.